A braking force is the force a car exerts on itself to slow down. In a car moving forward, like this one, when we apply the brakes, we create friction with the tyres. This causes them to stop spinning and create more friction with the road. To make things simpler, we can just refer to this process as applying a braking force, which is directed opposite to the car's motion. But why does this make the car slow down? Well, remember that by Newton's second law, the acceleration of an object is proportional to the resultant force acting on it, and this is represented by the equation F equals ma. Since the braking force is directed opposite to the car's motion, the acceleration will also be directed opposite to motion. This means that the force causes a deceleration. Now let's see how this relates to braking and stopping distances. The greater the braking force, the shorter the car's braking distance will be for a given speed. Remember that a braking distance is the distance travelled after we apply the brakes in a car, but before we come to a stop. It makes up part of the overall stopping distance of the car. Here we have two cars with different brakes. The first can apply a braking force of 5 kilonewtons, while the second can only apply a braking force of 2 kilonewtons. If both cars travel at the same speed and apply their brakes at the same time, we would see that the first car has a shorter braking distance. But why is this? Well, remember that a stronger force means a stronger deceleration. So since the first car has a stronger braking force, it also has a stronger deceleration, and it will lose all of its speed or decelerate in less time. Since it takes less time to lose its speed, it won't travel as far during this process. But what can affect how strong a braking force is? Well, if the brakes are damaged or worn, then the braking forces will be weaker. Here's a simple design for the brakes of a car. When we press on a brake pedal, this component presses down to create friction with the tyre. The brakes are made with a rough material, and each time we use them, the friction with the tyre wears down this material so they smooth out over time. As they're smoother, they won't be able to create as much friction with the tyre and so can't make as strong a braking force. This increases the braking distance of the car. But it's not only the brakes that get worn down. Worn tyres will also decrease the effectiveness of the braking force. It's important to keep track of the condition of both the brakes and the tyres. Cars won't be allowed on the road if these aren't up to scratch and their braking distances are too long. Let's look at why worn tyres will decrease braking forces. Here we have the front view of a new tyre on the left, and then one that's seen a lot of use on the right. Notice on the left we have this groove pattern, which helps to create more friction with the road when the tyre stops spinning. However, on the right, this pattern has been worn down. So when the tyre stops spinning, there will be less friction with the road, meaning we have a weaker braking force. There are other conditions that can affect braking distances, but for your exams, you only need to know about brakes and tyres being worn down. Make sure you can recall both of these factors and explain why they affect braking distances.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!